Techniques for writing software. When a piece of software needs to be produced, the problem to be solved is likely to be far more complex than the calculation of the perimeter of a rectangle. An algorithm like that is easy for a human being to be able to think about because it is so short. However, most useful problems involve such complex algorithms that it is not possible to consider them in one go. For this reason, problems are normally divided up into a number of smaller problems, each one of which can be solved separately, and then combined to give a solution to the whole problem. Consider that you have been asked to produce a solution to the problem of computerizing a set of traffic lights in the center of a town. The problem is a very complex one, but if it is divided into 1. How is the data going to be collected from sensors and stored in the system? 2. How is the decision going to be made about the changing of the lights? 3. How is the data collected from the pedestrian crossing and then stored? 4. And processed? 5. What outputs are necessary, and how are they controlled? Then each problem becomes more manageable. This sort of approach to problem solving is called a top-down approach, in that we started with an original problem, the top, and split the problem into smaller and smaller parts until they became manageable. When each of the individual problems has been solved, the solutions are combined to produce a solution to the whole problem. These individual parts of the solution are known as modules. There are other advantages in this sort of approach. More than one person can be engaged on solving parts of the same problem simultaneously, consequently the problem should be solved more quickly. Different people are good at different things, so our company uses Aisha to solve the problem of collecting the information from the sensors, because Leon is not very good at that, whereas he is an expert concerning controlling things using a computer, so he does the processing module. Last month, our company produced a similar solution for a set of traffic lights in a different town. The sensors used were different, so Aisha still has to produce her module, and the number of roads is different, so Leon will still need to come up with a solution for his module. However, the lights and other output devices being controlled are the same, so we might as well use the same module that we used last time. This happens often, that one of the modules is the same as one used previously. Because of this, software firms store the modules that they have produced so that they can be used again if the chance arises. Collections of modules like this are known as software libraries. Because the algorithms for the modules are so much shorter than for the whole problem, it is likely that the person producing a module will make fewer mistakes. Also, because the module is quite short, it is much easier to spot any errors that have been made and correct them. This means that the finished software should be more reliable when it is being used. One way of describing the modularization of a problem is to use a diagram to show how the parts fit together. Don't worry about such diagrams at the moment, we will meet them again in Chapter 1.7, but only at a very simple level. They will become more important when we want to explain our project in Module 4 of this course, though the emphasis will be on the explanation, not the drawing of the diagrams. If we imagine the same problem, and start with a control module, then realize that we have to provide an input module, and so on, the problem will still be solved, although the approach is the opposite to the one that we have just considered. This type of approach is known as a bottom-up approach. Although the outcome is the same, it is a far more dangerous way to approach the problem because the final outcome has not been considered and may not be arrived at by the most efficient algorithm. Because what we are doing is really to choose a library program we have already written and then add other bits of program to it in order to arrive at a solution, it is called bottom-up programming as opposed to top-down design.